application. Kind of joins what's happening in the world, but I'll make this little segment very U.S. focused because after all, this is where you are. But what we're on the cusp, and you'll see through here, of providing basic safety information from the infrastructure, from the vehicle, to benefit all road users. And we'll show you this. I don't want to tell you in advance all the detail. But this is precipitated on 20 megahertz by the FCC for them to start by granting a waiver to deploy. Right now we're doing this under experimental license, number one. Number two, a final rule. Final rule means certainty. There's some finality to it, right? So what we're going to show you is what could happen. The City of Las Vegas, working with our partners like Compsignia, which provide these boxes, which we provide some of the invention that goes into it, has equipped much of this route with roadside units, which is an infrastructure investment because it takes basically a common goal here of having the safety. We have an onboard unit here. This is an aftermarket onboard unit, so your imagination could go wild as one of several paths, but ultimately we want to see it in cars that are production. And so this can't happen until the FCC does basically these two steps. But what we're going to show you is the standardized message exchange so that you can have this V2X safety. X equals and much of it you'll see this focus, the infrastructure. X could equal other vehicles. Ultimately and aspirationally, X could be pedestrians or other vulnerable road users. We'll show you a little bit of hints of this as we go along. Excuse me. You'll see a standardized message being displayed, which you can pinch and make larger. I'm not looking at a tablet right now, so so if you pinch that in, so the green, no, the other way, sorry. You'll see some red dots, and you'll see, I don't see it right now, an intersection. You got to pinch it out a little bit. Can I? I'm just looking at one tablet, which is being pinched a different way. So pinch it out. Out. The other way. I'm sorry.
Zoom in.
Yeah. Zoom in. Sorry if I get the directionality wrong. I'm not really good with directions. So you'll see us, the green dot. Mm-hmm. You'll see intersections that come up. Those intersections will be displaying signal phase and timing. So we're not going to put you in a dangerous situation where there's red light running. But if you knew with your car through the signal phase and timing, it would be able to give you an alert if you're going to run the red light or if there's any other crossing path types of violations. So we index a lot of this demo. The first four intersections, the first four events would be the intersection and the provision of this SPAT. So I'm looking here, I don't know if others can see, we're not here yet.
Nothing yet.
So we're not.
You have to turn the corner.
No, I guess we turn the corner. So actually, it's just a good segue into perhaps. So this is done at a certain radio frequency, which is kind of like very adjacent, which is spawns a whole bunch of questions you could ask to unlicensed Wi-Fi. This is a 5.9 gigahertz. What does that mean? It can propagate, but not perfectly. And it can go around corners, but not perfectly. But the go around corners is an interesting proposition because there's no other Eagle vehicle safety sensor that can look around a corner. And so the SPAT is pretty important, but it's not perfect, right? Because at 5.9 gigahertz, we're talking millimeter waves is something that's on the order of about 5 centimeters in length. So if you imagine something going like this, it can't go around every corner, right? But it can kind of sort of do it. So it can't go around deep foliage, which is why I spoke to early when I said that you should pinch a little bit. But what you'll see is a bunch of blue lines. Dark blue means that's the ingress lane. The light blue in this representation is the egress or going out lane. You see little dots that look like the tip of matches. The green one means the green light, and the red one means the red light. So what's powerful about this is that this is a standardized way of interfacing to the traffic signal controller that provides with certainty the signal phase, which would be pretty darn important in virtually any safety endeavor at a signalized intersection.
We're stuck behind an autonomous car.
Yeah.
Never gonna go.
The last time I went on this, I just started talking when we moved, so I'm sorry that there's a lot of uncomfortable silence here. But any questions? This is a great time for me to answer
Well,
questions.
it kind of brings up the question of how do you interact or complement an autonomous vehicle?
Well, that's a great question. I guess I have a leading question here. Right now, it's what we at Qualcomm at least call informational safety, because we differentiate this from something that actually actuates a throttle, brake, and steering. So this is safety that would be providing an alert to a driver. Certainly, we aspire to get into integrating this into an AV suite, but we as a community, and there's a long litany I could give you as to why we're not quite ready yet, but we are absolutely ready to provide this basic safety. It says it may stop suddenly.
Go suddenly.
Okay. So can people see these green
Nothing yet.
lines? You gotta.
Nothing.
So,
They're supposed to be dots or something.
well, you have 4 of those.
Okay, great.
So I wonder, hey Len, is this included by the truck? The fact that we can't see the spat right now?
No, because the spat's actually going to be on Las Vegas.
Okay, I got disoriented. My apologies. That's because we're not in line of sight of any intersection. Well, traffic picked up the last hour.
Oh, yeah.
Okay.
So I guess we turned on Las Vegas, we'll get
We'll see
them on the
that.
side of the RCUs.
So, the OBU, you see the shark fin right here? This is meant actually for external application, but basically it's just the housing. And this particular one is an aftermarket one. Ultimately, obviously, we want a variety of paths to deployment. Aftermarket is one. This would be ideal, as you can tell, for a fleet vehicle. But really to happen at scale, one would need OEM commitment as well as vehicle OEM commitment. And so we have a variety of form factors, and certainly they're working assiduously globally to make this happen. My last ride had a whole bunch of folks from China. So, basically because I'm filling a vacuum here while we wait in traffic, this is happening at scale in China. The spectrum is allocated. We like to point at China as an still emerging success story in this field. They have the exact same spectrum allocation that we aspire to in the U.S. in the early days. At 5.9 gigahertz, the exact same 20 megahertz, which is interesting because the China SKU is very much like the U.S. SKU. So the path of deployment is really fairly straightforward here. Because these are global OEMs who are working to make this happen. Now, you start seeing something blue. So if you open up, there you go. So you see an intersection. Those I can only get feedback on one that's in my line of sight. Yeah, that's right. And so again, as I described, like matchsticks. So that each lane is delineated. So it's not as if you, the driver, will see this, but we're just representing what the application processor sitting in your car could see. So you get the certainty, signal phase, and timing as you go through this intersection. And we're going to go through 4 of these intersections. The city of Las Vegas, and actually Clark County, has done a very good job of leaning forward into this technology, as have a whole bunch, not every, but a whole bunch of road infrastructure owner operators. They really believe in this. So why do they believe in this? This is, again, spectrum that doesn't have to go through a mobile network operator. Now, we at Qualcomm love mobile network operators, but we understand that the network communication is complementary and different than a vehicle safety communication. So this is short-range broadcasting, standardized messages. You see the spats there. Signal, phase, and time. They even have names, right? And map, which is an obvious name. And there are a whole bunch of others that a couple of others that we'll show here. We'll only show you these elemental signals. Now, what are they? It's when I like right now. I'm talking. I'm broadcasting. I'm not acknowledging you at all, right? So I am broadcasting. So imagine these broadcasting their state. If it's a vehicle, 10 times a second. If it's an intersection, it doesn't have to be so much, maybe twice a second. But it can be more. And what it does is it broadcasts. There's no session. So you don't have these types of delays that you would expect to have a session. You don't have these Wi-Fi getting access point, to work. You just have a broadcast. So you're just saying, here I am, here I am, here I am. A little bit more complicated than that, but not much more, 10 times a second. And so if every entity can broadcast its state, you as the receiving entity can integrate that. So you kind of have a state map or situational awareness. So that's all it is. So this bus is getting situational awareness of the intersection state. They'll do this through a few intersections. This is the I to V or V to I proposition. Why is this important? Because in early days, try as we might, there won't be a whole lot of cars, right? We have a base of over 200 million cars in the U.S. Market penetration is necessarily small. The ones who are first early adopters need to have this intersection to talk to in order to provide utility. And you can start to provide utility and safety for citizens, so this is a good policy move. Another reason it's a good policy move if you have a captive fleet of ambulances and they have this, and you don't have to have the whole lot, and you intersection that equipment, you can preempt the signal. Now, I wouldn't recommend that for your average car, in fact, no one does. Which means you can make it green when you're responding to an emergency. You have a captive fleet of buses, you can prioritize a signal, as you don't want to turn everything green just for buses. There's some traffic engineering reasons that I can talk to you till the cows go home later on. But you might want to extend the green just a few seconds longer to let that bus go. So there's equity and people who are not choice riders in consideration. So there's a whole bunch of really good policy moves as to why cities like Las Vegas and others are implementing this. Oh, hey, Lan. So you have the advantage of sitting near the front. You can zoom in and zoom out here. So the first few intersections will be just that. So actually this is where we have the uncomfortable pause where I ask, are there any questions? Yeah, thank you. Please break my monologue. Yes.
Well, I'm seeing things on other people's screens that are not showing up on mine.
That's because you're not.
You need to zoom in.
Yeah, man. Okay,
Yeah.
zoom in further. Got it.
So what's the holdup at the FCC right now? Are there any specific complaints or
Well,
issues
no,
with the waiver,
they're-
or what's taking so long? I've been following this for a
Well,
while.
I mean, just
Politics.
just to be fair, and don't want to criticize any entity.
Sure.
But the FCC is taking into account all the stakeholder inputs, and other stakeholders include the DoD, which operates 30 fixed satellite tracking installations. It includes the Wi-Fi interests, which want unlicensed use adjacent. This is why some spectrum was taken over. But there is an overwhelming public record of support for this, and very little opposition now that there's only 20 megahertz of rare bad left. And so the FCC is considering, as we talk right now, I hope as we talk right now, they're working on granting waivers, which is step one. Because it's different than experimental license. You can deploy on a waiver. And it's kind of like, they crack the door open, you stick your foot in it, and that's what we really want. Then they have to do a final rule. But this has taken a lot of deliberation because this is a complex topic. Sure.
What's the red flags for?
The red flags should be, the first red flag will be a BSM broadcasting car. So we thank you for zooming out a little bit. So what this is, so we've done a lot of V to I or I to V, showing the signal phase and timing. The end goal is to have high market penetration, to have other cars to broadcast its here I am signal, so it's BSM or basic safety message. In order to make this a really safe experience for you, we don't have moving cars, swirling in and out of this, eliciting safety alerts. We have one that's parked. So in all of this, you're going to have to use your imagination a little bit in order to understand that we are providing, and you can see demonstrated in front of you, that's over-the-air technology to make this happen. The applications are the purvey of auto OEM for the car is ultimate, or whoever provides the aftermarket software set. So you'll don't want to spill the beans too much, but there's another reason that there is a different color, and you'll see that a little bit later. Now, Glenn, can you point us to, is there an orange here? This one or something? So, well, please interrupt me and flag when you see one.
There's a gold one. I'm taking RS3.
Okay. So basically, these roadside units look like an access point, except there are a few more antennas. You have some for diversity.
This one's okay.
Okay. But it's nice that it's the system here that kind of blips. And so they're fairly straightforward to install. I mean, you see a lot of access points already with Wi-Fi. The interface and traffic signal controllers will specified by standards. So basically, this has been, for better or worse, this community's been working on this in the order of 2 decades. So virtually all the interfaces, to include from the radio on up, have been standardized, which is good. That's basically we're ready to deploy is the long and short of this.
This would be a good time to point out the BSM coming from the vehicle over there.
Okay, so at this junction here, this where you see this island where this V is one of the if you expand it a little bit, right there, you'll
green
see
one?
a BS. That's green. I'm sorry. That's a car. That's another car. You're a car. You're both green. So the BSM, which is I focus on standards, but it's important since a diverse community of implementers. For interoperability, you have something called the basic safety message, which is 10 times a second. Here I am with a little bit more. A little bit more includes where I was, path history, and then where I will go, a path prediction. And this is what makes this also powerful. A, it works well at intersections, which are very dangerous. B, there's no other sensor from another vehicle that can predict with high certainty where you are going. But you as a vehicle, understanding the steering wheel input and the yaw, know where you're going, so you can, in a model that we have in standards, in an interoperable way, tell everyone else where you're going in the near field.
So most people use like navigation, right? Even though where you're going, can they tap into that and then you know for sure where you're going?
Oh, but this is a great question. Thank you. So this is local. In fact, I've heard a DOT person call it hyperlocal, which actually I like. So we're talking about the vehicles that are only dangerous to you. So for navigation, you don't need high positional accuracy.
No, what I meant was, if the other car is using navigation, so they already have their route planned, couldn't they then tell the other cars where they're going?
That could happen. That's an implementation detail. But the standards allow that. But what I focus on, both internally and externally here, is what we're trying to message here is that these basic elemental standards and messages are very important for day one applications. You don't have to get fancy, but you can get fancy in implementation. Now the red, I misspoke a little bit earlier. The red is I don't want to make you all experts in standards, but it's called the travel information message. You see this pedestrian crossing? So that's the implementation here. So in this particular implementation, it provides an awareness that there's a pedestrian crossing coming up ahead, which will be useful. There are other implementations that might keep that quiet and would provide it only if there's a pedestrian there via camera, or maybe they push a button and you see the flashing lights. So we have a few routes of this. We wanted to show this even though you see an intersection coming up. We index a lot on intersections, but not totally. But we believe that all these types of day one applications are within grasp. Not only us, but implementers in China, and hopefully soon enough, regulators in the U.S., but certainly the road operator community believes in this. Witness that you see this ready-made demo for us with some help from our Comsignia friends. A ready-made demo for us because Las Vegas and other jurisdictions are implementing or deploying this, but only on experimental license. This is why I keep on focusing back to the policy imperative that we need FCC to move in order to embolden more and more deployers. Yes?
Once you have FCC approval or everything you need from a legislative perspective, what do you expect will foot the bill for installing the...
Great question. Because the bill payers are manifold. One part is the taxpayer, but we notice, for example, the Infrastructure Investment and Jobs Act, or the bipartisan infrastructure law, has an unprecedented amount of money of which this is eligible. In fact, in the NOFOs, or Notice of Funding Opportunities, you call RFP by normal people, these NOFOs have C-V2X, or connected vehicle technology, as an eligible category. So, certainly for the public sector, the bill does get footed by sometimes with cost share, so that means with the local agencies all the way up through the federal government. On the vehicle side, certainly the cost would be reflected in the cost of the vehicle. I'm not going to go and tell a bunch of journalists what the prices are, but it's eminently reasonable if you look at the equipment. It's not a tremendous amount of equipment. It's cheaper than many other systems you can imagine. OEMs who want to see it happen, say in other global regions, are doing this. Because obviously, if you want to provide, ultimately you want your customers to live. Okay. So those of you on this side of the bus, I feel like the pilot saying the Grand Canyon's on the right side of the plane. But I missed it.
It's like right on that.
Then feel free to yell it out next time you see it. Okay. Okay. If you look near the top of the lights, again, it's not that exciting. I need some more technical help here. So, in case you couldn't tell, Lan is part of the engineering team that implemented it on the bus.
What is Qualcomm providing and what is Comsignia providing?
Great question. Obviously, we are as a global company working in standards. We work with other standards contributors to make this underlying technology really work. And we provide the chipset, us and our competitors. Qualcomm, so Comsignia and their competitors basically provide the entire integrated package, which are the electronics, the hardware security module, because there's some security that I haven't really talked about here, and the software stack, which is written to be compliant with standards. So they basically provide, in essence, the box.
What's mounted up on the light poles?
Those are Comsignia roadside units, or RSUs. This is a Comsignia aftermarket OB unit, or onboard unit. And with each of these, it is our chipset solution. In this particular case is the SA9150, which is our first single-purpose C-V2X transceiver. We also provide a hardware accelerator, another chip. Any other questions? So, you didn't go and see the Hoover Dam, and you didn't hear lots of screeching tires. But the whole idea was to give you, imbue with you, that in a regular transportation experience, the applications radio in certain places do a whole lot for vehicular safety and other road user safety. And it needs the participation of all the stakeholders who are involved in the transportation system. I kind of focused a lot on the FCC because that's the problem du jour, or the issue du jour. But certainly it takes the resolve from the local entity, in this case you have it, and it takes a resolve from the people who produce cars. They're a little bit quieter, and they kind of have to be, because you're not going to do a product announcement on something that is not regulatory, that has regulatory headwinds. So this is why we're working pretty hard with allies to break those regulatory headwinds. So I believe there's not a whole lot more.
I have a question.
Yes.
So, what are some of the other markets where you see this actually being broadly applicable? I know there's been in Europe, there's been a lot of back and forth on some people are committed to DSRC over there, but there's also momentum behind C-V2X. So, what's the situation in Europe, and are there any other countries or regions that are interested strongly in C-V2X outside of China, the U.S.?
Okay,
global picture.
Okay, I'm glad you brought up China, because
China's obviously
China's a shining star,
Yeah.
and leaning forward on this. Europe is an interesting discussion. Certainly, there are those who favor C-V2X, but in Europe, unlike the U.S., the spectrum hasn't been taken away.
Okay.
So the way that we like to view the world, and we believe is a correct but easily understood model, is that the types of applications we're talking about here are basic safety, which is C-V2X, or LTE V2X, release 14 and 15, for those of you who follow 3GPP. The 5G V2X and our Sidelink is a discussion in Europe, is maybe even eclipsing DSRC down the line. But it cannot be a discussion in the US because there's not enough spectrum. And we have to deploy soon, or we could lose spectrum. So both in China and the US, it is CV2X or LTE V2X release 14 and 15. Because to get, it's like you got to walk before you run. So get basic safety taken care of. And certainly we believe that once you get that, the FCC will open up the spectrum, obviously once the societal benefits are become very clear. But we got to kind of like put something in the air soon in order to make this happen. This is why we pay for this bus. We encourage you to listen to this, which is a nonfiction story, but we think is very compelling and absolutely necessary story.
Quick question. How future-proof do you think the hardware will be, whether it's in the in-vehicle hardware or the roadside hardware?
Well, the way you future-proof something, and maybe you have a different model, but part of it is my historical bias. I've been doing standards before I got into this automotive BU for years and years and more years than I care to count. So basically stable standards and interoperability is what you do. Or as you advance the standards, you make sure that there's a progression path, right? But let's take the standards out and talk about once you start to deploy, it has to be future-proof, because basically it's going to last in your car for 10, 15 or more years. So this is why we want this basic safety, which will apply to us today, but our children, our children's children, right? Because there'll always be intersections, or at least some juncture where you have crossing path hazard. There'll always be vulnerable road use. So we think that ultimately that type of technology can last forever, really. And then you would have advanced safety coming with more spectrum. And that would be, we at Qualcomm understand, and so do our competitors, that you can, like your mobile phone, it has several generations of G. So ultimately in deployment, even though people argue that the standards don't show interoperability as they advance, the implementations are what really counts. And so we believe that we can add on to this given more spectrum. Any other questions? Because otherwise it'll be like a riot.
So aside from broadcasting the location of your vehicle or syncing the timing of lights, what else can V2X do?
Oh, that's great. I have someone trying to call me, but I'll ignore that. It's a great question, because in standards we have a whole bunch of application protocols. I tend to, and I think it's important, and when I talk about this, is talk about safety, because that's the imperative. But there is a tolling standard that could be implemented in a very sensitive way, and that and I don't want to say this pejoratively, but it would certainly upset or change the tolling industry. But if you had all these in the vehicles, do you really need 900 megahertz transponder is what some people are thinking. And it also changes the business model. It can also provide weather information or spot weather information. There are standards to do this. And those of you who are really into really nerdy things on transportation, it's been called the Road Weather Information System, RWIS, these little sensors. So if you get this local weather, that would be pretty interesting and a complement to safety.
So does that take the temperature sensor in the car and use that to broadcast?
It takes the local temperature and provides it to the car.
Okay.
Ultimately to the driver. There are we call it this idea, this pedestrian that showed up, this pedestrian, we call it the traveler information message, which is generic. So virtually any type of feature that's local and pertinent could be brought. At our booth, and maybe this is a good time to mention. So we have a booth that has a private area, appointment only. But we deliberately put C-V2X on the outside to show some of these other applications. And what are we put? Because we have very clearly, we're a commercial company. We have power line communication chip business. We noticed the integration of EV and C-V2X is interesting on highways because you can start to have access to C-V2X RSUs, and you can start doing, for example, if a car encounters an incident, it carries that and would send that Mayday message to the nearest EV charger. And there are things, so we actually show that. So in the public area of the booth, you see C-V2X bicycle, which is cool. It's by Trek. You'll see some videos. You'll see a crosswalk with a flashing light. We really believe in it, so we're front and center with this. And you also see an EV charger, and if you stay around and ask questions, you'll see that we've integrated C-V2X in it. So we got C-V2X on our brain here because we believe it's important, again, because safety means a lot to all of us. The rest of the stuff is private. So, this is obviously I focus a lot. There's a lot of policy in here, but again, just a few policy strokes of the pen left, and we're there in the U.S. we believe.
When will that happen, do you think?
Well, I can't predict it. Just to give you a personal story, I have been working on V2X since 1998. So maybe it's me. But again, never have we been close to the finish line. At least in the U.S. and again in China, some people say, I would say we're still very close, but we've crossed the finish line. There's a mass deployment. Any other questions? Because again, as I warned you, it's 15 minutes more with the traffic jam out and about 15 minutes back. So yes.
So you mentioned Las Vegas having a program. What other cities are you working with?
That's great that you asked. So in our booth, you'll see that we're doing something with Bellevue. Now Bellevue is an interesting city. It's nice. But it also is a Vision Zero city. So those of you who follow Vision Zero, that says basically that, started in Europe, that every fatality is unacceptable. So Vision Zero means zero fatalities. So they've implemented, so in this BIL monies, they have worked with us and T-Mobile to deploy some high concentration of safety. So C-V2X is part of this. We like that for many reasons. We are very careful. We're not a consulting company. We want to see our technology applied. But we work very carefully here because this shows that network communication, T-Mobile, is complementary for pedestrian safety with direct communication, which we want to see. So Bellevue is one. Another that we're working with is the city of Ann Arbor and the University of Michigan. We have worked with Virginia DOT on the city to show work zone safety. That's very important to road operators. We're working with a variety of Texas entities. If you look at the request for a waiver, you'll see that there's what we call, and I know it's a legal term, it doesn't sound great, it's called a Me Too waiver. But we've talked to many of the entities, New York City, Texas DOT, Maryland and DOT to do Me Too waivers. Notice that you said city, and I'm answering mostly with states. And that's kind of the way that who has the wherewithal to apply for these grants? Generally, large entity states or metropolitan planning organizations, less so cities. Cities often, but not always, New York City is a prime example, follow the state's lead in technology. So, we're trying to lift something. So we work a lot more with states than with cities. But companies like Comsignia, who try to sell boxes at intersections, they work a lot with cities. But we're trying to basically change the whole ecosystem here. So we at Qualcomm work a lot with states. Any more questions, or I can leave you in silence, or I can break out in song and dance. You don't want that.
We'll get it on video.
So can you talk a little bit about some of the automakers? I'm familiar with some of them, but I'm not sure if anybody else. Some of the automakers have been doing some C-V2X related demonstrations.
Oh yeah, a lot of demonstrations. Again, announcements are in the U.S. are for a variety of reasons. You don't want to announce generally, although Ford has said some interesting things.
Just talking about projects that have
a lot with Audi. They're leaning forward heavily with us on this. Under the auspices of the 5G Automotive Association, which has most of the global automakers, we've done a whole host of demos globally. And so that's basically the who's who of automakers. And in Europe, it happens to be, PSA, or actually not Stellantis and Renault. And China is with a whole host of automakers. We've done a lot with Ford, obviously, under that, and certainly, again, Volkswagen Group writ large, but mainly Audi.
Do you see any enthusiasm from the startup OEMs, perhaps, of kind of being a
That's a great question. Yeah, we do. And I just can't leave it at that. But they're very, very, very. They can pivot quicker, right? And so it's interesting. So again, everything from us. Our model is that the FCC has to lift the regulatory uncertainty. Then you'll see a lot. I mean, the better model, to be very frank, is what's happening in China with an NCAP. So China NCAP in 2025 will spawn a whole bunch of startup production in order to be eligible. So we're not even close to that in the U.S. But those are the things that precipitate the most excitement. So the startups see something, but if you're a startup, you have a minuscule market percentage. What really needs to happen is the large market OEMs have to commit. And again, obviously we and you have sources within. We know them quite well. They wouldn't want to say anything until the FCC gives clarity.
I know you mentioned the regulatory headwinds earlier, but can you repeat just like what exactly we're waiting for the FCC to do?
Okay, our model and the 5GA model is there's a joint waiver request, and then a whole bunch of Me Too's, and I've lost count. I probably should be better prepared, but we can post facto give you these numbers. But a whole host of OEMs, small market penetration like JLR and Audi, but bigger ones like Ford, plus a whole bunch of companies like Comsignia, but importantly a whole bunch of states and cities like New York City have asked for a waiver to deploy. So that lifts the yoke of an experimental license. You can really deploy. So if you have an aftermarket use, you can deploy with high certainty. So that was the first step. And that's pending. It's been pending for a while. There is a huge public record of support, to include support from the NTSB, from both sides of the aisle, the House Transportation Committee, from basically a bunch of associations just recently, the Auto Innovators, ITS America, 5GAA, NEMA, on and on. So the idea is to get this waiver out the door, to get basically these seedlings to start to sprout. But the really to really make them flourish would be a final rule, which would happen after the waiver.
And
So the
that's a broad, basically spectrum release of spectrum. Is that what that is?
No, so the spectrum is out there. The FCC has said you shall have 20 megahertz, and there was a big brouhaha because we previously had 75 megahertz. But now that people have gone through the stages of grief, realize what it is, now people are starting to say we got to deploy or we can lose more spectrum. But the final rule has things like outdoor operation of Uni4, that is of unlicensed Wi-Fi, and things that could provide harmful interference to adjacent C-V2X. So there are some details that have to be worked out as to what the emission limit should be. So it starts to get technical, and sorry if I'm starting to get into what may be perceived as jargon, but basically we have to draw a wall between unlicensed and that. The other thing we have to do is make sure that handheld devices, such as a phone, that connects to an AP access point that has this adjacent channel operation. That, if it's a meter beneath the shark fin, is very dangerous because you can't have any V2X. So there are some details that have to be come through and put into the final rule. The waiver to deploy proposes these emission limits and is based on industry consensus, at least the transportation industry consensus. So that's like step one to get your foot in the door. And also, again, it starts to get a whole host, not every stakeholder, but a whole host of stakeholders to want to deploy, to include cities like Las Vegas. And I'm not speaking for the city of Las Vegas, notice I said cities like Las Vegas. Does that answer your question? Any more? I know that we're getting there, but we're not there yet. I didn't say this would be exciting. In fact, the goal of this is really, we want to have a boring and safe trip. Right? Ultimately, there'll be other things where you see an AV vehicle being stuck at a traffic signal.
Sorry, one more question.
Sure.
What about from the commercial vehicle side of things?
It's a great question. So many of the commercial vehicle OEMs say it's a Class A tractor trailers. What about those? The manufacturers are, ultimately these are like Navistar International is owned by Volkswagen Group. Freightliner is owned by. So they're cognizant of this. There's work being done. Again, I tend to, because I track standards, I'm kind of a geek like that. In SAE, we've come up with a standard to do articulated vehicle, to do a PSM with articulated vehicle. We also know that the Federal Motor Carrier Safety Administration is different than NHTSA, and there are paths. All that being said, this is great, but you need market penetration. Unless you own a closed system like a city, where you can have your own emergency vehicles go through these intersections, or a transit vehicle, you still need market penetration, and freight vehicles generally do not. And then some of these that we talked about, these Class 8 vehicles we talked about, are mainly made for highway use. Now, highway use, there are some use cases, but ultimately, this technology is best used in the early days in arterials and collectors, roads like this. Any more questions, or?
What's the status with intersections? Because as you mentioned, obviously one of the early adopters for this technology will be essentially early parts of the transportation system will be cities and intersections. So what's that penetration look like right now? Are they waiting on the final ruling mostly?
Yeah, same thing.
Ready?
These deployments that you saw here.
Yeah.
I would almost and really honestly put these in quotation marks until the waiver. Then you take the quotation marks off. So the status of there's the Infrastructure Investment and Jobs Act. A year has passed, but if you do the math, About $570 billion is allocated for transportation, which is good. So basically, and again, this is an eligible category, which is good. But until you get a waiver, not a city, but the people or state, the people who apply will be a little bit hesitant. So obviously we're predicting that the pen stock will be open. But so now you have visionary road infrastructure on basically local and state agencies who want to see this happen. And so for example, I'll take one, Georgia DOT, and they said this publicly, has a vision to do this. I spent a lot of time in Atlanta as a result, but Georgia DOT has decided to equip all the state-owned intersections with C-V2X, not under this discretionary money from the BIL, but under their formula funds. So this gets a little wonkish, but those of you who see how transportation being funded is basically your gas tax, which gets returned to you to some extent, sometimes a lot more, by formula. So that would mean it's being mainstreamed. So if you're willing to, I can give you the Georgia DOT point of contact who said this publicly. So that would be an extreme positive story to really believing in this technology. Others are taking a wait and see.
Right.
And frankly, many other local agencies are not even that aware of it because they're too small. This is why we focus on the states to provide leadership.